So let's again determine the vertical and horizontal asymptotes and the x and y intercepts and then sketch this function. So let's find the x and y intercepts. So let's find the y-intercept first. So y-intercept. So where is that going to happen? Well, that's going to be when x is equal to 0. So let's write that in now. So we'll say y is equal to, this become 3 times 0 plus 6 over 0 squared minus 2 times 0 plus 1. So you can see all these zeros canceling, and what we're left with is 6 over 1. So this is just y is equal to 6. Okay, so I'll draw that in now. So there you go, so we have a y-intercept there. For our x-intercept, so x-intercept, that's going to be when y is equal to 0. So that'd be 0 is equal to 3x plus 6 over x squared minus 2x plus 1. But we only really care about the numerator of this equaling 0, right? Because if the denominator is equal to 0, then that's going to be a non-permissible value, right? That's going to be a different case. But if we want it to be 0, it's really the numerator. So let's just focus in on the numerator here. So 0 is equal to 3x plus 6. So we'll subtract 6. So we get negative 6 is equal to 3x. Divide by 3. So we get x is equal to negative 2. All right, so let's put that one in. So negative 2. Okay, so we're starting to piece this together. Next, I'm just going to move over to this side of the screen. Let's factor the denominator here, just so we can see our non-permissible values a bit more clearly. So this would be the same thing as f of x is equal to 3x plus 6 over, and this would become, so factoring this, be x minus 1 times x minus 1. All right. So in this case, it looks like we have a non-permissible value or a vertical asymptote. So we have a VA at x is equal to positive 1. All right, so let's draw that in now. So next, let's see what's happening on the left side of that vertical asymptote and on the right side. So we'll take the limit. So we'll say, okay, what is the limit as x approaches 1 from the left of 3x plus 6 over x minus 1. And to make life easier, this actually make it a little easier if I call this x minus 1 squared. Just make it nicer to think about, I guess, when we start picturing numbers that we're throwing in. Because now what I'm interested in here, I know it's an asymptote, right? So I know that as I approach 1, I'm going to go like 1 minus 1. I'm getting very, very close to 0, right? But it depends whether or not I'm positive or whether I'm negative. Since I'm squaring this, I can actually assume that this is always going to end up being positive, right? Because even if it was negative, if it was on the like the left side of 1, it's coming out positive because I'm squaring it. So this is coming out positive. You can think if you had some number very, very close to negative 1 here in the numerator, if you add 6, this is still going to be positive no matter what. So I've got a positive divided by a positive, very, very small positive. We're approaching positive infinity. All right, so now let's go from the other side. So we'll say the limit as x approaches 1 from the right. So what's happening there? So that'd be 3, so of 3x plus 6 over x minus 1 squared. Now, we already decided that the denominator here, it's going to be positive no matter what, right? It would have either way on this one, but good to know it's going to be positive and very, very close to 0. The numerator, if I throw in, a number very, very close to 1, it's still coming out positive, so this thing is still going to be positive. So again, it's going to be approaching positive infinity. All right, so we know that our graph is approaching infinity from the left, and it's approaching it from the right. And now what's left is just to figure out what's happening with our horizontal asymptotes, right? I'm assuming this is going to come down through this point. But let's leave it there for now. We'll figure out the horizontal asymptote now. So for the horizontal asymptote, so let's say, okay, so the limit as x approaches negative, I'll say positive and negative infinity. I'm going to be able to do this in one move, and the reason for it, if we write this out, this would be 3x plus 6 over, and then our function. I'm going to write it just in the original form. X squared minus 2x plus 1. And the reason why I wrote it that way is because it's clear to see that, you know, the degree of the numerator is 1, the degree of the denominator is 2. So in this case, we are going to be approaching 0, either from the towards positive or negative infinity. So this is going to have a horizontal asymptote at 0. Okay, so let's draw that in. Now, one thing to note that may seem strange here is that we're crossing this asymptote. You can cross horizontal asymptotes. We just can't cross vertical asymptotes if we're dealing with a function. So that's okay. So what's going to happen here is if I'm piecing this together, we had a y-intercept, and then it has to cross through here, right? It has to go through that point. And then at some point, it must turn back, right? It must turn back and then start approaching our horizontal asymptote. And then on the right side, it's a little bit more straightforward. We're just going to be approaching our asymptote there.